Download this code from codegive.com, link in the description below. OK, let's dive deep into DNS server name resolution. This will be a comprehensive tutorial covering the fundamentals, practical examples, including code, and common issues you might encounter. What is DNS, Domain Name System? Think of DNS as the phone book of the Internet. Humans use memorable names, like www.google.com, but computers communicate using IP addresses, like 142.250.185.142. DNS translates these human-friendly domain names into the IP addresses that computers need to locate servers and other resources on the network. Key components **** domain name *** the human-readable name, example example.com. *IP address ** the numerical identifier of a server or device on the network. DNS server ** a server that holds DNS records and responds to queries. DNS resolver, client, the part of your operating system or application that sends DNS queries to DNS servers. DNS records * entries that map domain names to various resources, IP addresses, mail servers, etc. 2. The DNS resolution process, a step-by-step walkthrough. 1. User action ** you type www.example.com into your web browser's address bar. 2. DNS resolver * your computer, or a router, uses its configured DNS resolver to initiate a DNS query. The resolver looks in its local cache first. If the answer isn't there, it proceeds. 3. Recursive query. To a recursive DNS server, the resolver sends a recursive query to a recursive DNS server, often provided by your ISP or a public DNS server like Google's 8.8.8.8. Recursive means the server will handle the entire resolution process on your behalf. 4. Root servers * the recursive DNS server starts by contacting one of the root DNS servers. There are 13 logical root servers, but they are distributed globally. The root server doesn't know the answer directly, but it knows the address of the authoritative DNS server for the top-level domain, TLD, in this case, .com. 5. TLD servers * the recursive server contacts the .com TLD server. The TLD server knows the address of the authoritative DNS server for example.com. 6. Authoritative DNS server * the recursive server queries the authoritative DNS server for example.com. The authoritative server holds the actual DNS records for that domain. 7. Answer * the authoritative server responds to the recursive server with the IP address, a record, associated with www.example.com. 8. Caching * the recursive server caches the answer for a specified time, the time to live, or TTL, to speed up future queries. 9. Response to client * the recursive server sends the IP address back to your computer's DNS resolver. 10. Connection * your computer's browser uses the IP address to establish a connection with the web server at www.example.com. 3. Types of DNS records. Here's a breakdown of common DNS record types. *A, address, record * maps a host name to an IPv4 address. Example www.example.com. A 192.0.2.1. *AAAA, quad A, record * maps a host name to an IPv6 address. Example www.example.com. AAAA 2001 DB81. *Name, canonical name, record * creates an alias for a host name. Example blog.example.com. Name www.example.com, This means blog.example.com points to the same IP address as www.example.com. Name records cannot be used for the root domain, example.com. *MX, mail exchange, record * specifies the mail server responsible for accepting email for a domain. MX records have a priority value, lower is preferred. Example.com. mx10mail.example.com. *text, text, record * contains arbitrary text data. Used for various purposes like domain ownership verification, SPF, sender policy framework, and DKIM, domain keys identified mail. Example.com. Text v equals SPF1 MX all. *NS, name server, record * specifies the authoritative name servers for a domain. Example.com. ns1.example.com. *SOA, start of authority, record * contains administrative information about a DNS zone, primary name server, administrator email, serial number, refresh time, retry time, expire time, and minimum TTL. Every zone must have an SOA record. *SRV, service, record * specifies the location, host name and port, of servers for specific services. Used for protocols like SIP and XMPP. 4. Code examples, Python. Python's DNS library makes DNS resolution relatively straightforward. You'll need to install it first. Here are some code examples. Explanation ***** import DNS.resolver ** imports the DNS.resolver module, which is the core part of DNS for making DNS queries. *DNS.resolver.resolver creates a DNS resolver object. You can customize the resolver's configuration, example specify the DNS server to use, if needed. By default, it uses the system's configured DNS servers. *resolver.resolve, host name, this is the key line. It sends a DNS query to resolve the given host name for the specified record type, example a 4 IPv4 address. The resolve method returns a DNS.resolver.answer object containing the results. For data in answers * iterates through the results. A host name can have multiple IP addresses or multiple MX records, so you might get several answers. *redata.address, for a records extracts the IP address from the redata object. *redata.preference and redata.exchange, for MX records extract the preference and exchange server from the MX record. *error handling * the try, except blocks handle common DNS errors. *DNS.resolver.nx domain, the host name does not exist. *DNS.resolver.timeout, the DNS query timed out. *DNS.exception.DNS exception, a general DNS error occurred. *record type * change the second argument to the resolve method to query for different record types, MX, NS, text, AAAA, etc. *redata.strings for text records * the strings attribute contains a list of strings that comprise the text record. V. Troubleshooting DNS issues. DNS problems can manifest in various ways: websites not loading, email delivery failures, etc. Here are some common causes and troubleshooting steps. 1. Incorrect DNS server configuration ***. Problem * your computer or router is configured to use an invalid or unreachable DNS server. Solution *. Asterisk check your network settings. Asterisk make sure your DNS server settings are correct. You can use your ISP's DNS servers, or use public DNS servers like Google's 8.8.8.8, 8.8.4.4, or Cloudflare's 1.1.1.1, 1.0.0.1. Asterisk flush your DNS cache. Asterisk this removes any cached entries that might be incorrect. On Windows, use IP protocol configuration /flushns in the command prompt. On Mac OS, use sudo scotchy flush cache, sudo killal hupm DNS responder. On Linux, the command varies depending on the systemd resolved service, or nscd if either of those are installed. 2 DNS propagation delays. Asterisk problem. When you change DNS records for your domain, it can take time for the changes to propagate across the internet. This is due to caching. Solution. Wait. The most common advice is to wait. Propagation can take up to 48 hours, although it's often much faster. Check propagation. Use online tools, example https://www.whatsmiddens.net/ to check if your DNS records have been updated globally. 3 incorrect DNS records. Problem. The DNS records for your domain, example mx, are configured incorrectly. Solution. Verify your DNS records. Use online DNS lookup tools, or the nslookup command line utility, to check your DNS records and make sure they are correct. Consult your DNS hosting provider's documentation for instructions on how to configure DNS records. 4 firewall issues. Problem. A firewall might be blocking DNS traffic. Solution. Check your firewall rules. Ensure that your firewall allows outbound DNS traffic, typically on port 53, both TCP and UDP. 5 router problems. Problem. Your router might be having DNS issues. Solution. Reboot your router. This can often resolve temporary network glitches. Update your router's firmware. Make sure your router has the latest firmware installed. 6 ISP issues. Problem. Your ISP's DNS servers might be experiencing problems. Solution. Use a different DNS server. Switch to a public DNS server like Google's or Cloudflare's. Contact your ISP. If the problem persists, contact your ISP to report the issue. 7 local host file override. Problem. The host file has a configured override. Solution. Check your local host file. The location of the host file is /etc/hosts on Mac OS and Linux, and C/Windows /system32 /drivers /etc/ hosts on Windows. Make sure your domain to resolve isn't listed with the wrong IP address. 6. Advanced topics, brief overview. DNSSEC, DNS security extensions. A set of security extensions to DNS that provide authentication of DNS data. This helps prevent DNS spoofing and other attacks. Dynamic DNS, DDNS, a service that automatically updates DNS records for a domain name when the IP address associated with that domain changes. This is useful for home servers or devices that have dynamic IP addresses. DNS load balancing. Using DNS to distribute traffic across multiple servers. This can improve performance and availability. Asterisk split horizon DNS asterisk configuring different DNS records for internal and external networks. 7. Key takeaways. Asterisk DNS is essential for translating domain names into IP addresses. Asterisk the resolution process involves a hierarchical query from the root servers to the authoritative name servers. Asterisk DNS Python is a powerful library for performing DNS queries in Python. Asterisk troubleshooting DNS issues requires understanding the various components and potential points of failure. This tutorial should provide a solid foundation for understanding DNS server name resolution. Remember to experiment with the code examples and explore the advanced topics to deepen your knowledge. Good luck.